All right, we are recording there, and let me turn this one on too. All right, this is session 7 for Math 120, February 21st, 2018. How are you guys doing? We come to the end. All right, let's have a prayer. Father God, we thank you for tonight. Thank you for this module, for everything that we learn about mathematics. Pray, Father, may it be that all of us see how you have used math in creation of this world, and how everything in this world, the mathematical pattern in the creation points toward you, toward an intelligent creator that revealed himself in the Bible, revealed himself in the person of the Lord Jesus Christ. Thank you for all these dear students. I pray that they will do good in final and all the remaining assignment for this course or any other classes that you are taking at the school here or any other school. Bless them, watch over them, and use them for your glory. Commit tonight into your hand. In Jesus' mighty name we pray. Amen. All right, so anything you need to, yes? I haven't graded it yet.
No, it's not up on my mark.
It's not?
There's quiz 2, midterm, quiz 3, final exam, comprehensive, that.
It's there, it should be there because people are taking it. Let me, just one moment. Go to lesson 6. Oh, it's right here. You see, for quiz 4, all you have to do, download the file, answer the 10 question, take a time limit for yourself, and then scan it back. Here.
Did you also notice that we didn't have
Number
5? I put that in my quiz.
Ooh, well, like you guys.
Yeah,
okay.
Yeah.
Okay. All right.
Just in case you didn't.
Okay, thank you for bringing that to my attention. Okay.
That was the extra credit for.
No.
No one got it.
Okay. Any question you guys have? So you're clear about
Any questions with the assignment 12? No.
okay.
You're awesome. I have to print it out. I knew I should have helped you.
All right. The lesson tonight is short because on statistics, we have covered many things in this course. It's on the statistic. We have covered number theories, simple mathematics, algebra, geometry. I just want you guys to know a few things about the statistics, the few essential issues, and I uploaded the PowerPoint for that. And there is that video under lesson 7 that goes in far more detail if you want to study more. And let me ease your mind. It's not going to be in the final. So I want you still to learn about some basic elements of a statistic. One of the things I want you to learn, and again, I'm going from the PowerPoint, it's under lesson 7, simple random sampling. It's a simplest sampling design. Maybe you guys in future, you may take some courses and you have to do some research. And they tell you have a random sampling. Random sampling is a kind of sampling in it that each element has an equal chance of being selected. Let me ask you this question. Is it a random sampling if you pick the names of people based on a phone directory? You know, the old phone directory when they used to be printed. Yeah, and it's also, you have to remember, it is systematized based upon people's last name, you know, so it's not random. To be random, I mean, you can use it if you just pick all over without looking, you know, just opening the phone book and, well, okay, this number, that number, this name, that name. But just by itself, it's not a random sampling because it's been categorized by people's last name. You know, you, for example, you list all the units in a population from 1 to n, and then from that population, you randomly, what the key is that they should not have connection to one another. If they have connection to one another, then your sample is not random. Maybe, for example, you want to interview a group of youth pastors to know about their experience. You're working on a project. You want to learn about youth pastors, how they, what's their experience, what's their effectiveness in their ministry. If you can look at the population, but if you focus only, for example, I'm going to focus on youth pastor in North County, San Diego. But that wouldn't be a random sample because you're focusing on one geographical area. People in that area have their own specific financial status, social status, maybe racial status. Wouldn't be a random sample. But if you take North County, East County, South County, West County, the central part of San Diego County, and just pick people from different churches, not just Anglo churches, pick people from Hispanic, Filipinos, Asian churches, all different backgrounds. Then yes, your sample, the more diverse, the more, the only thing that is related, connects them together is only one thing, that they are all youth pastors. Nothing else. Then your sample is a random sample. And the more diverse, more unrelated they are, the better your data. Because if you focus only, let's say, if you focus only on youth ministry in El Cajon, in East County, and if you focus on only Anglo churches or Hispanic churches, then you know you can do a research. Somebody maybe is doing a research among Hispanic churches. Okay, but then if you want to do that, don't limit yourself to East County. All over, maybe even other cities, other states. But you know, you can have random sampling within these groups, provided that you don't focus only on one area. Does that make sense? All right. That's random sampling is very important for research. If you know, for your projects, like you know, I did my doctoral dissertation. I had to interview a group of pastors, but I tried to do it to the more diverse they were. You know, I was focusing on my topic of my dissertation was how to preach Mark 16, the longer ending of Mark 16. You know, that's a controversial passage that everybody argues about it. I didn't try to prove that this is part of canon, or I personally believe it is part of canon. I have no problem with it. But that was not the focus of my dissertation. My dissertation was how to teach it. It's there, it's in all translation I've seen very few, maybe only one version that has taken it out completely. It's all there, and people know about it. And then I focus on Middle Eastern churches, because the significance of how Islam attacks the integrity of the Bible. I wanted to see, okay, how are we going to deal with this part of the scripture, which is questions even by Christians. But when I was focusing on Middle Eastern churches, I did my best to have my samples be taken from a diverse background. What I mean is different geographical location. Not everybody in San Diego. San Diego, Texas, some in Europe. You know, the more, if I had access, I don't, if I had access to some pastors inside Iran or some Islamic countries, then in fact, the more diverse and the better the result would become. Right, you following me? All right. Okay. Let's look at one example. For example, on page 675. All right, it says, for example, 1, a group of hotel owners in a large city decide to conduct a survey among citizens of the city to discover their opinion about casino gambling. So, what is the population? The population is a set containing all the citizens of that city. B, one of the hotel owner suggests obtaining a sample by surveying all the people at 6 of the largest nightclubs in a city on a Saturday night. Each person will be asked to express his or her opinion on casino gambling. Does this seem like a good idea? Now, here, questioning people at 6 of the city's largest nightclub is a terrible idea. The nightclub subset is probably more likely to have a positive attitude toward casino gambling than a population of the whole city. You see, here it shows that this is not a random sampling. If you want to have a random sampling so that your result your survey would be really meaningful, you should, okay, maybe one case you go and interview people at the nightclub. But you have asked people from the church or all different spectrum, all different segment of the society. You follow? All right. Now, there is something else called frequency on example page 678. That's, you know, like on that table, constructing a group frequency distribution. Use the classes 40 to 49 and all these different scores to construct a group frequency distribution for the 40 test scores on the previous age. Oh, okay, that's what we need. So, you know, there's been a 40 statistic test scores. So we want to find the frequency. And these are the results. If you look at that table at the top left of the page 678, that reddish yellow table, orange color table. So we have all these different scores for these different tests. Then you find out how many people they got in their score. Let's say there was a test. How many got the score between 40 to 49? 3 people. How many? The tally tells you how many got that score. How many got between 50 to 59? 5 people. Then all the rest. So you have 3 actually 6 people, 6, 1, 2, 3, 4, then 5 and 6. So you put the number of the student frequency are all over there. Then you look at it. Can you tell me what is the frequency of this whole test?
Did you take everybody that took the test and then did their,
Yeah, you look at column 3. You see the number of students. These are the frequency: 3, 6, 6, 11, 9, and 5. The one that is repeated more, here tells you the most frequency. Actually, the most frequency would be people getting between 70 to 79, 11 students, highest number. Okay. Are you guys following me? You understand what I'm saying?
is that also like same thing as like the average or the mean?
We'll get to that. These are building the foundation for that.
Actually, it wouldn't be that.
Okay, now here, the mean. What does it mean to have a mean, or the average mean of a number? You have, in this case, if they want to find the mean, they will add all the scores together and divide by the number of the students. Basically, if I want to find the mean of the score for this course, I add all the, the final percentage, the final points, not the grade points, for all the students, and then divide that by the number of students in this course. If you have these numbers, like you see that on the PowerPoint, 15, 13, 18, 16, 14, 7, 17, and 12. We have 7 numbers, and they're the sum of, when you add them together, you get 105. You divide that, you get 15. So the mean of these number is 15, which expressing that formula, X bar is equal, that bar means the mean. Sigma X, that sign means sigma. Maybe I better write it on the board for online student too, but it's in the PowerPoint. Let me get this. We have, let's see, this sign means X bar is a mean is equal. This is called sigma. Okay? Sigma X over N. N is the number of the data, number of items. In this case, that I would, the example that I said about this course, the number of students in this class, 10 students. Then I add all the points, the total points of each student together. That would become this value, and then divided by 10, you get the mean points for the student in this class.
So in that case, it's kind of like PowerPoint where the sigma is actually just the sum.
Yeah, sigma is the sum. If you have, what is it called, on your computer, I'm sure you have it, I have it in my, oops. This, I don't know if you ever worked with Microsoft Office Excel. That's basically, that does that. Yeah. Yeah. That's what it does. All right. So that's me. The mode. Now, when we're talking about the mode, you're talking about which number occurs most, the most occurring number. So in the PowerPoint, you have all those numbers. Which one occurs most? You look, just, you know, you look at the numbers, 2, no, you know, that's the tally comes. 4, 6, 8, it's 12, happens 2 times. It's 3 times actually. So the mode for these numbers is 12. Which you can, in order to find it, you can make a table like the one that we are looking at on page 678, put all the numbers on the first column, the number of times that they happen, just put a bar, and then on the third column, write the you know, numerical value. That tells you the one that has the highest numerical value is the mode. You know, the mode, for example, if you have this list, the mode for this list, we have 4 has happened 3 times, and 8 has happened 3 times.
So you could have more than.
Yeah, 4 and 8.
Is there a minimum number of modes you do?
If I had more numbers that happen that occurred 3 times, I should have had them.
Okay, because the reason I was asking, if like you have 4 and 8, I get that. But let's say you have 4, 8, and 10, you wouldn't actually total up the time.
I would say the mode of this number is 4, 8, and 10. These are the most occurring numbers. But that rarely happens. You know, if that happened, that tells you that your sample is not random. Okay. All right. Mid-range. Now, mid-range is different than the mean or average. Mid-range would be average. You can say it in a way. It's a, you know, kind of a layman average. Mid-range is you know, you have a set of data, you take the lowest value and the highest value, add them together, divide by 2. That would be the mid-range or average. That's different than mean, okay? In the mean, what we do, for example, in the example that I have in the PowerPoint, you have, if you wanted to find the mean, you will add all those dollars amounts and you would divide them by what number? No, the mean. I'm talking about the mean.
Oh, the mean.
5, because there are 5 different dollar amounts. But if you want to find the mid-range, you find the lowest, which is $150, and the highest, which is $672. Add them together, divided by 2. That gives you the average. That's the average, but that's not the mean.
Because that's like what the average spending or whatever.
Okay. Now, the range, you know, if I wanted to find the range for these dollar signs, you take the highest, which is 672, and you subtract it, you know, 672 minus 150. That gives you the range. The highest to the lowest data. Difference between largest and the smallest observation. If, you know, in that example that I have done there, the highest, whatever value, it doesn't matter, age can be, is 14, the lowest is 1, the range is 13. All right. Now, a key, very important thing in statistics is standard deviation. It tells you how much you deviate from the mean. And basically, as you can see it in the PowerPoint, you have all these numbers. S sub of X is a standard deviation. In order to find that, in fact, your textbook has a very good you know, step-by-step way to find that. Really go to that. The standard deviation, you know, when you do that, you're measuring dispersion. On page 701 of your textbook, if you want to find out how much you're deviating from the mean, what you have to do, first you have to find the mean. Then for each data that you have, you take that data item, subtract it from the mean. You multiply it by 2. In this way, you make sure that it's not negative. You raise it to power of 2. I'm sorry, not multiply by 2, raise it to power of 2. Then you sum it together, and then you divide it by the total number of your data. Yeah. So you find the mean, first of all. For each data that you have, you take that data minus the mean to the power of 2. So in this way, it's not going to be negative. The summation, that the sign that you have here, the sigma, it starts from I equal to 1 to the n, means all the data, right? You understand that? Now the first I is 1, so then it goes all the way. If I have 10 data, my n, the maximum number for n would be 10, right? Then you divide that by the total number of data minus 1, and then you get the square root. That gives you how much you can deviate in your sample from the mean of your sample. Now, you may wonder, what's the use of this? Let's look at one example on page 704. Yeah. Or let's say, for example, example 5 on page 704. It says, shown below are the means and the standard deviation of the yearly returns on two, is it? No, I'm sorry. That's checkpoint 5. Example 5. 2 fifth grade classes have nearly identical mean score on an aptitude test, okay? But one class has a standard deviation 3 times that of the others. So they got the scores on that test, they found the mean, they went through this formula, they found the standard deviation. The mean for both classes are very close to each other, but one of them, the standard deviation is 3 times the other, okay? All the factors being equal, which class is easier to teach? Okay, without reading the rest of in the textbook, can you tell me? Yeah. There are 2 classes, 5th grader. They took an aptitude test, and we find the mean, meaning we add all the scores, divide them by the total number of students, and we find that the mean for these 2 classes are very similar. But when you do the standard deviation, you find out that one class, the standard deviation is 3 times the other. If the
Deviation up or down?
Oh, well, I mean, let's say the mean for the score was 80, okay? But when you do the standard deviation, let's say the standard deviation for one class, just to make it simple, is 5, the other one is 15. The standard deviation has to always be positive because you get a square root of that.
I think the easier class is the one that's doing better because that sounds like it's a.
What do you mean by doing better?
Well, okay, the deviation that actually is more to the higher level. In other words, like you said, they're both very similar, right? But one's 3 times.
Okay, what does it mean that one class, the standard deviation of the score for that test is 3 times larger than the other?
The deviation is 3 times, okay, so 80 is the score, right?
Yeah.
Okay, so if it's 3 times 80.
So no. Let's say standard deviation for one of them is 5.
Right.
The other one is 15.
Okay, so it's between 5 and 15.
Let me,
So it's like 85 and 95.
85 and
Oh, no. Whoever's got the smartest kids.
okay, they find the mean for the, here is one class, you have a class. They find, for example, the mean for this class is 80. The other class, let's say, is 78. For example. Very close. But, so you look at this, they are very similar. In fact, this one is a little bit higher than that one. But the standard deviation in this class is 5. The standard deviation in this class is 15. What does 15 mean? It means how far we can disperse from the mean. We can go this way or that way. It means that in this class, you have students who got 65. Or you have students that they got the maximum 95. Okay. But here, the lowest student got 73. And the highest got 83. 5 points. But here, 15 points. Are you guys following? Now, you tell me which class is easier to teach.
The one with the 15.
Why?
Well, okay, the reason I would say it's easier is because even though the standard deviation is 15, what you're seeing though is that the higher scores, you have a better class participation or interaction. Whereas this here, you're the 73 to 83, you're not necessarily having as much.
No,
But that's just my guess.
Look, that means you have student in this class that got 65
The worst.
and goes all the way together. You have somebody 95, but you have somebody 65 and lower, and then 68, 70, something like that. This is harder
Yeah, they have a lot.
because you have much diversity, variety of students. You have students, whatever subject that course is, who are not that very good in that subject. You have some students who are very good, in fact, better than the other class, but you also have these students.
So one class you get more apt grade on the curve than you would the other.
So this one is harder to teach. But this one, even though the mean is less than this class, because the students are closer to the meaning that their understanding of the subject, their comprehension is closer to one another, it's easier to teach because you can work with them and raise them to higher level. They are closer to one another in their understanding, comprehension of the subject. So the higher the standard deviation, it tells you that you're going to face difficulty. Mean standard deviation means if this is the mean, the bigger the standard deviation means that you can go more this way or more that way. You swing more. It's better that standard deviation be less. In any kind of research, the less the standard deviation, it shows the result that the number that you have is more reliable. You are closer to the mean. You can have a class that everybody is either D and C, and somebody gets A+. Yeah. But that's a harder class to teach because you have a wide range. You remember the range? You have a wide range of students. All right.
Yeah, just looking at it personally.
Let me give you a hint for final. Make sure that you remember those interest rates, how to calculate interest rate, things like that. And basically, that's it, guys. Any questions?
So we have the assignment 13, 14, the report.
Yeah.
I still have some things that-
Right. If you needed more time past Sunday, I'm flexible.
I'll be, as long as that.
But you just remember that there's something that the school has set up with this Populi, that it closes. You know, I have no control over it. All right. Then
Thank you so much.
God bless everybody.
Yeah, it was actually a lot better than what I thought meant when I was like, ah.
Okay, I'm going to stop this recording and also stop the video.